our next speaker is Mohamad Al Mdfaa with the talk Mapping the Unseen, Unified Promptable Panoptic Mapping with Dynamic Labeling using Foundation Models.
Hi.
Hi.
Okay, so let me share.
Okay, everything is okay.
Nice. Okay. So, hello everyone. My name is Mohamad Al Mdfaa. Today I am here to present to you my recent work, Mapping the Unseen, Unified Promptable Panoptic Mapping,
Still nothing from your side.
It's strange. I don't know what happened.
Now it's okay.
Okay, so you can see me now, right?
Yeah, it's nice.
Okay, so let me introduce the Mobile Robotics Lab, where I have my PhD. So Mobile Robotics Lab is a research group at Scoltech, and our goal is to work on the full autonomy for mobile robots. To do so, we are working on different research topics, which are currently includes sensor fusion of different combinations of IMUs, images, and point clouds, point cloud alignment, 3D mapping, localization, and SLAM, robot path planning, visual odometry, reinforcement learning, etc. So if you feel interested, please come and join us. Now I'll move to the main topic. So as an overview for UPPM, I will start by mentioning that the problem of semantic mapping, it's still a significant challenge due to the growing demand for intelligent machines that can comprehend and interact with the complex environments. In the conventional methods, however, we are limited by many factors, including the predefined semantic classes that can recognize. Thus, which makes these methods sometimes ineffective for handling novel or unseen objects in new environments. So in response to this, we introduced UPPM and worked on UPPM, Unified Promptable Panoptic Mapping, to utilize recent advances in foundation models, which enables on-demand level generation. So in UPPM, we introduced what's called a dynamic labeling, dynamic labeling strategy, and we used it with panoptic mapping techniques in order to have maps that has adaptability and versatility to different scenarios while maintaining high level of accuracy in map reconstruction. Now that I gave a kind of formal overview about what we are doing, I'll try to give here something like less formal, let's say. So the main problem we're working on could be summarized like this. So let's imagine that we are in a case of having such objects like a few set of chairs, and each of these chairs have different characteristics. So we have here armchair that has medium size and like a unique color, and we have office chair with black and high back. Dining chair, it's made out of wood and it has medium size. All of these chairs if we go back to fixed labels and the models or the approaches that use a fixed set of labels, like Coco classes, for example, all of these chairs will be categorized as like chairs, like all of them just similar. So this will give us like limitation in terms of like being able to comprehend and understand the scene better and utilize this information to do subsequential tasks, like, and different tasks. So in dynamic labeling, we try to approach this gap by utilizing the open vocabulary and maintaining the consistency of categories. So with this, we'll be able to we will be able to answer such queries like show me the light beige armchair and show me the wooden dining chair, etc. So this is the main idea. And here, if we go back to mapping, so with such approach, we will be able to have interactive scene exploration and object retrieval using natural language prompts. This is we will be able to do that with such technique so for example here if we focus on the table in the scene, so it has like multiple semantic labels, but all of them will be attached to the same object, and we will be able with different users having different description to the same object, we will be able to find the object in the scene. Now, how did we manage to build such a solution? So in UPPM, we have different inputs to utilize. So we have post RGPD data, and in the output, we have reconstructed map. And between them, we have different modules, starting from the visual linguistic feature extraction, or what we call VLFE++, where we extract the set of open vocabulary classes, and we do some post-processing steps in order to have a better quality set of classes. Then we use semantic textual similarity, and in this step we use embedding models in order to find the closest match between our open vocabulary classes, find the closest match in the set of Coco classes. So with this step, we will be able to find the parent class for this for our class and Coco classes, and we will be able to define or to predict the size of this object in the scene. After that, we use we use an approach called ground and dino in order to find the objects in the scene, to detect the objects in the scene. But in this approach, I mean, we noticed there are some issues like redundant objects being detected, and so for that we used post processing also. We use non-maximum suppression in order to keep only the trying to keep only the unique objects in the scene. So in order to keep some consistency. And yeah, so after that, we now we have the segmentation. We use segment anything in order to find the segments, to find the masks of the objects, and we utilize all these as input for with multi TSDF mapping in order to find the reconstructed map. Also introduced what's called a unified semantics into the panoptic mapping, and in this by this what we mean is that we implement the dynamic labeling. So dynamic labeling, again, it's like if we define it, we can define it in this way. It's the process of assigning semantically unified categories to the detected objects in the environment while preserving the open vocabulary levels. So we want to keep the, if we can call it, the richness of different labels that we can assign to the same object, but we want to keep the consistency and the simplicity of having a category ID for the same object over different frames. So here, if we talk in like unified semantics in action. So here we have 3 sequential frames. In each frame, we have the same table in the scene, the same table, but with different open vocabulary labels. So with dynamic labeling, we assign the same category ID. So all of them are classes, all of them like assigned to the same category ID. So while keeping all labels available. So it will help us in like talking to the map, finding the potential object in the scene that we are looking for. Here, now again, I mean, we show comparison between with and without unified semantics. So PPM. So when we started working on the project, we came with PPM, Promptable Panoptic Mapping, without unified semantics. So in PPM, we don't have this consistency, and as you can see here, we have this is 3D semantic segmentation, and for the same class, we have different colors. And that's because we assign different labels and different category IDs for the same object multiple times over the sequential frames. So to resolve this issue, we introduced the unified semantics, and so while we keep the different labels, we assign same semantic category. So if you didn't get what I was saying here again, I show you that the result is that for UPPM it looks like this. So although in PPM we have different levels over the sequential frames, like we call the same chair. We call the model called it blue seat one time, then called it blue chair. And so we try to unify the levels into one and assign to them the same category ID. So in our project, we used different data sets, starting from ScanNet to flat dataset and RIO. 2 of these datasets are real-world datasets, and one of them is simulation data. Here we can I can show you how it looks like the map reconstruction after using UPPM. Here I can show you the 3D instance segmentation, and here the 3D semantic segmentation. And here I'm showing the quantitative results for applying UPPM against two variants, like against mask dyno. And mask dyno, we have 1,203 different categories that mask dyno can recognize, and these categories are under LVSI data classes. And also we compare the UPPM with the ground truth segmentation, and we see the results. Here we used the ground, we measured the error from ground truth to reconstruction and reconstruction to ground truth. As you can see here, comparing ground truth to reconstruction, it has it punish much harder than reconstruction to ground truth, and that makes sense. And so we use the chamfer distance in order to merge both of them into one metric, and also we compare the coverage. So here we can see that the reconstructed map with UPPM it still has high coverage and the best chamfer distance. And also now we have the richness in levels and consistency in terms of we have now a map that we can utilize for different applications, from localization to I don't know, navigation, etc. So for more details, please don't hesitate to visit the project webpage here. And if you have any questions, please don't hesitate to contact me directly, or now you can ask me if you have any questions. Thank you for listening.
Thank you very much. Did I understand it correctly that your main contribution is this unified semantics, or also am I clear? This unified semantics is like a hierarchy of semantic classes, or something more?
Yes, that's correct. I mean, one of our main contribution is using this unified semantics. I mean, without unified semantics, we couldn't use this richness of labels. I mean, and integrate it into this hierarchy. So for that, we used as I said, we use the dynamic labeling, and dynamic labeling actually it implements the unified semantics, semantically unified categories.
Okay, thanks. We have a question from the chat on the slide 12.
Mm-hmm.
Why do you use intersection over union metric for assessing segmentation quality?
Yes. Actually, yes. I mean, this question is very valid, but our main focus was on the downstream task, which was reconstruction. So we didn't. I mean, we have some experiments. Prepared some experiments in case if needed to do intersection over union and other metrics. But my supervisors had this suggestion that let's only focus on the downstream task, and yeah, so we moved in that direction. But yes, you have a point.
Thanks. And another question: what is the performance of UPPM?
Yeah, this is also a very good question. Although I mean, we didn't add any. If you check the paper, I didn't include any time estimation in the paper, but the code will be available for anyone to try. And based on the experiments, I mean, it's for three if on average, like for 300 frames, we almost need like 4 minutes or so. By using like small, like relatively small GPU like T4, but yes, it's valid. Maybe I will consider adding that time estimation to the repository later.
And what about the image resolution?
Yes, for image resolution, we are using like 512, and it's totally fine. I mean, like as I told you, I mean, like we use this size, and with this we have almost like 4 or 5 minutes to utilize almost 300 frames.
Okay, thanks. And another question: what are your next steps in this direction? Are you going to continue this work, or maybe go in another direction, or something like that?
Yes. So right now, my focus is more into navigation. I want to utilize the map in different tasks. So yes, the work is not like this is not the end. I will continue working. I have many things learned on the way. I think I will try to push to resolve these issues in the coming work. But basically, the main focus will be on navigation.
Mm-hmm. So you will focus on downstream tasks like navigation, and maybe make some changes on the way in order to boost navigation metrics. Am I correct?
Mm-hmm, mm-hmm.
Okay, I see. That's really purpose-driven development, I should say, navigation-driven development.
Yeah.
Okay, thank you for your talk. Wish you good luck, and see you next time.
Thank you. See you.
Bye.